Okay, guys, so focusing on trapezoids and kites today, the first thing we're going to do is talk about what a trapezoid is, what it looks like, all the characteristics about it. This is a picture of a trapezoid. Most of you think of a trapezoid as basically a pyramid with the top cut off. That's going to be a special type of trapezoid. It's called an isosceles trapezoid. But a trapezoid is going to be any four-sided figure, so a quadrilateral. Okay, so it's got to have four sides, a quadrilateral, with exactly, and that's key, with exactly, that word is the word to underline, to star, to do something to, with exactly one pair of parallel sides. Everything we've dealt with so far had both pairs of opposite sides parallel. We are not going to have that anymore. Only one pair of our sides is going to be parallel. In this case, that's the ones with the little triangles on it right here. Bless you. You can see that these outside pieces, the TP and the RA, are not going to be congruent to each excuse me, not going to be parallel to each other. I apologize. Not going to be parallel to each other. Now, in a trapezoid, there's a lot of names, so you need to know that. The parallel sides are called the bases. Okay, so this is a base, this is a base. A lot of times you'll see it written as base 1 and base 2 with the little sub numbers, just to distinguish between them when we talk about formulas, because we're going to be doing area formulas and other things with them later on, so it's important you know they're interchangeable, base 1, base 2. It doesn't matter which one you call which. It's just the bases. Okay, the ones on the outside, the non-parallel sides, are called the legs. So this is a leg. This is a leg. They don't usually assign numbers to those because they're not used in the formulas for the area, so they're just called legs. Okay, then there's these things right here, these angles, these two angles, and these two angles down here pair up, and I'll draw a line to kind of connect them. These two and these two, see how they're both on the same base? They are called base angles, and that's going to be important later on. Base angles do something special in a certain type of isosceles trapezoid. And just so you can see it, guys, because it's going to come up soon, in a very soon, very close set of notes, guys, that is also going to be your heights. The height is going to be between these two bases. It is always going to be at a right angle to those two bases, so you're always going to see it at a right angle to those two bases, and it is going to be called the height. Every single time you have that H. I don't know why I put it so far away. Height. The H. It's just given by H. So you know. One of my concerns is that people think trapezoids only face this direction. Please understand you can have trapezoids that face different directions. I'm going to draw one out here just to kind of give you an idea. This is not a great drawing, but I just want you to see that a trapezoid could go this way where the bases are on the sides. I like to make sure you're clear on that. You could also have the right angle be on one of the legs, and this would be not only a leg, but it would also be your height. Okay, so this would be a leg, this would be a leg, and then these would be your bases. We could call this one base 1, this one base 2. It doesn't matter which one you call which. But just so you see it, I just want you to see that trapezoids don't always have the bases on top and bottom. That's important for everybody to understand, that it doesn't have to be that way. Also, that the height could be one of the sides, one of the legs. Trapezoids don't have much special about them until you make them into isosceles trapezoids. So we're going to talk next about isosceles trapezoids and what it is that makes them special. That's the main thing we're going to focus on, but you do need to know the basics about a trapezoid before we get there. So, anybody still writing? Okay, here we go. So, in an isosceles trapezoid, again, this is what I think most of y'all think of a trapezoid as. Again, it's like a pyramid where they cut off the top. The biggest thing is it is a trapezoid in which the legs are congruent. It is a trapezoid in which the legs are congruent. Guys, it just means those outside pieces are going to be equal to each other. That's all it means. Because of that, though, you create lots of special things. You've got all these properties down here that are going to be true because of it. And these things are going to be true, and it's going to be what you see a lot of your algebra done by, and the finding the missing numbers done by is in these isosceles trapezoids. So the first one says that diagonals are going to be congruent. Diagonals are congruent. Ooh, can somebody name the diagonals in this picture? Because not everybody sees them in a trapezoid. What's the diagonal here? Name one of them. Oh, guys. AC. Good. That's one of them. So AC would have to be equal to or congruent to, if we put the symbol above it, BD. Good. AC would have to be congruent to BD. That is exactly correct. Okay, the next thing that we know is going to be true is about the base angles. Base angle pairs are congruent. Base angle pairs are congruent. Now, we got to remember where the base angle pairs are. Remember, they're connected on the lines that are parallel. So the base angle pairs are going to be this one right here and this one right here. Those two are going to be congruent to each other. So angle A is going to be congruent to angle B. And then down here, D and C, these are also base angle pairs. Angle D is going to be congruent to angle C. These two are always base angle pairs. These two base angle pairs are always going to be congruent to each other. Okay, the last one is something old. Guys, if you have parallel lines, listen to me. If you have parallel lines and you have two angles like A and D, they are on the same side of the transversal. They're on the inside of the parallel lines. So that makes them what? Ooh. A and D, I thought I heard somebody say it. What would A and D be to each other? They're not the same, you can see that. Let me draw a picture. I draw two parallel lines cut by a transversal, and I talk about this angle and this angle. These are what kind of angles? Same side interior, and same side interior are going to be supplementary to each other. So same side interior angles are supplementary. Guys, what does that really mean? Thank you. They add up to 180, just so we can put that out there. So A and D would add up to 180, and then B and C would add up to 180, just so you can see what it looks like in the picture. Okay, guys, anything just on the basic properties of an isosceles trapezoid? That's weird to say. Anybody have any questions just on those three properties? Okay. Anybody still writing? Guys, if you are, you can tell me. I just need some of y'all work on other stuff like you're drawing and doodling. I can't tell. Okay, I'll come back if I need to. Okay, guys, here we go. Mid-segment. We've done mid-segment before. This is not new. It just happens to be, instead of in a triangle, it's going to be in a trapezoid. Guys, we've done mid-segments before. It's just an average. It's just add and divide by 2. That's all it is. The mid-segment of a trapezoid is going to be connecting the midpoints right here and right here. See how it's in the middle on this side and on the middle on this side? Because it's in the midpoint. It's hitting the midpoint. So that mid-segment of that trapezoid is going to be connecting those midpoints. So your formula to find that is going to be to average the top and the bottom to get the middle. To do that, you would add TR plus PA, and you don't put a line above it because we're talking about their measurements, and you divide by 2. That's it. Add the top and bottom, divide by 2. Average them. Add the top, add the bottom, divide by 2. That's going to give you the one in the middle. So if I gave you like a basic one right here, let's say I put an X here, I put an 8 here, and I put a 12 here. X 8 12. Okay. X 8 12 would be set up like this. Guys, MN is the 8. It's going to go in front. It's going to look like this. 8 equals. TR is the one on top, so it's going to be X plus the one on the bottom, PA, is 12. And we're dividing by 2. Now, you know how to solve a two-step equation. To solve a two-step equation, you are going to multiply both sides by 2. That's going to make this, I'll pull it up here, 16 equals, what happens to the 2, guys? Cancels out completely. You don't do anything with it. It cancels. And we get just X plus 12. From there, you're just going to minus 12, and 4 equals X. Now guys, put your number back on your problem and see if it even makes sense. Look at TR. It is the shortest one out of all those. Is it the shortest one out of all of those? Yes, so it works. The numbers make sense. If it went 12, 8, and your other number was like 20, would that make sense? If it went 20 up here, big, middle, and then back to big again? No. So it does need to make sense. Think about your answers, guys. Sometimes you can check things and see if they're even reasonable. Okay, so let's go on from here. Mid-segments with, oh, no, sorry. Finding measures first. I apologize. I thought it was that. The mid-segment ones are the next ones. I had done both the problem sets afterwards. Okay, guys, very basic. D and C, I need to find this angle right here. I need to find this angle right here. So, guys, base angles in an isosceles trapezoid are going to be what? Congruent. So, they tell us it's a trapezoid. They would need to tell you it's isosceles. I'm telling you it's isosceles. For some reason, the marks didn't get on there. They got on this picture. I don't know why they didn't get on this one. But if this is 67, then this one's going to be what? 67. So D is 67. And then how am I going to find this C down here at the bottom? What do I know about these two?
180.
180. There you go. They add up to 180. They do, because they're supplementary. Same side are supplementary, so we subtract from 180. 180 minus that 67 leaves us what? 113. Perfect. Nice. All right. Questions? Base angles are congruent. Same side are supplementary. Good deal. Let's keep going. On the next one, NL, this length for this diagonal right here, which diagonals in a trapezoid look really weird, but that is the diagonal of that trapezoid. This whole thing from here to here is 34. It tells us that KO is 8 right here on this part from just here to here, and it wants us to find MO. We'll call it X. Guys, they're equal to each other. So we're just going to set 34 equal to X plus 8, because it's those two things put together. Basic equation, one step, just minus 8 minus 8. And what's that give you? Is it 22? 26. I thought you said 22. That's why I was questioning you. That's why I was confused. You're good. It was my fault. I just heard you wrong. So it's going to be 26 equals x. Absolutely. I was trying to do the math over in my head. That's why it sounded like I was going, really? So, good. 26. Okay. Anybody else? Questions, concerns, anything about it? Okay. Here we go. Mid-segment problems. Add and divide by 2, guys. Add and divide by 2. That's all it is. It's an add and divide by 2 concept. So, because we have 2 problems, I'm going to do it this way. I'm going to split this problem in half just so I can write numbers on one side for one and numbers on the other side for the other one. So I'll start in red on this side. So it tells me AD, the one at the top, is 7. It tells me BC, the one at the bottom, is 3. And it tells me EF, the one in the middle, is the one I need to find, X. Remember, the formula is the one in the middle is equal to the top, 7, plus the bottom, 3, divided by what? 2. Every time. Top plus the bottom divided by 2. So guys, that's just arithmetic. 7 plus 3 is going to put us at 10. And 10 divided by 2 would put us at 5. Okay, do the same thing on the other side. I'll switch back to blue just so we can see this one in a different color. EF is going to be 15. AD, the one at the top, is going to be 18.2. And we don't know the one at the bottom. We don't know that BC. So guys, what number goes first?
18. Oh, 15.
It's the 15. 15. 15, good. 15. The one in the middle always goes first. And then it's the top, 18.2, plus the bottom, x, all divided by 2. Now guys, it doesn't matter if you write x plus 18.2 or 18.2 plus x. It makes no difference whatsoever, just so we're clear. It's addition. It doesn't matter on the order. It doesn't make it different in any way. First thing we got to do is get rid of that denominator. We already talked about how to do this. It cancels out my denominator completely. 15 times 2 puts me at 30 equals 18.2 plus x. What's the next step?
Subtract 18.
Good. Got to get that 18.2. It's positive. The only way to make it go away is to minus that 18.2. I leave the decimals up to y'all. Y'all tell me what that is. 11.8. Thank you. Equals x. There we go. BC right here would be 11.8. Again, make sure your answers make sense. When you put those answers on there, they go in order, like you would think. From big to small, small to big, whatever it is. Check and see if they make sense. Alright, anything about mid-segments before we leave these and go to algebra? Okay, guys, are we done with the front? Yeah, please.
Why didn't we put the
Take your
why
time.
did we put the 15 in front of
Absolutely, because the one in the middle is always the one that we're finding the answer to. Since we already have that answer, it has to go in front. So the formula you can think of, it's always the middle equals the top plus the bottom divided by 2. Does that help out a little bit? Okay, good. Guys, if you need another way to think of a formula, I will always try to help you do that. Please ask. Thank you for asking. It is always the one in the middle equals the top plus the bottom divided by 2. I appreciate a question like that. Okay. You got that? Everybody's good? Okay, let's do the algebra because you're going to need that formula to do these with. So again, it's always the one in the middle. So in this case, it's the x plus 2 equals the top, which is going to be 8, plus the bottom, which is going to be 4x minus 10, all divided by 2. Now guys, you got to get rid of that denominator, but you got to do this correctly. So this 2 right here, this whole thing is one big item. So when I multiply by 2 on this side, it's going to cancel out that denominator. But I've got to multiply by 2 on this side, and it's got to be times everything that's on this side. So it's going to be times 2 times 2, because these are separate items. There's no line underneath them. There's no one fraction underneath them. These are separate terms. So that's going to make this 2x plus 4 equals, now guys, on the other side we're going to bring down that 8 plus 4x minus 10. Now we have something to do that I got to make sure you do correctly. I'm concerned about this. This is that combine like terms thing. 2x plus 4 equals, now I would put the variable term next because variables come before regular numbers. 4x, when you combine terms, you do that. And then what is 8 minus 10? Negative 2. That's how you would write this. From there, you would minus 2x because you got to move all your variables to one side. It's going to make it 4 equals 2x minus 2. Add 2. We get 6 equals 2x. Divide by 2. And 3 equals x. Now guys, be careful. I don't know if the directions on the homework say to find the mid-segment or not, but if it did, you might have to plug it back in and find these lengths. This does not tell us that, but I just want to warn you because I, for some reason, think on some of the ones on the test, they might ask you that, or on the review worksheet, somewhere along the line, it's going to ask you to find those. All you would do is plug this back in into whichever ones, if it asks for all of them, or if it just asks for the mid-segment, you'd plug it back into here. I just want to mention that because plugging back in is something you've got to be able to do. It just depends on the directions. This didn't ask you to. Just saying if it did. Okay, for the last one of these before we go to kites, it's going to be the one in the middle, 2x plus 11, is equal to the top, which is 8x minus 12, plus the bottom, which is 10, all divided by 2. We're going to multiply everything by 2, times 2, times 2. This whole thing is one big item, so we multiply it times 2. It helps for some people to see the parentheses, put them around there because it helps them think of it as one item. Cancel out that 2, that's going to bring down 4x plus 22 equals 8x minus 12 plus 10. Now guys, if you can combine like terms in that step and do it right there before you bring it down, you can. You don't have to do this as 2 separate steps, but I do it because I need to show people what we're doing. But if you could have gone ahead and skipped to this where you combine like terms and write it as 4x plus 22 equals 8x and then combine these two together, that would have been okay too. What's negative 12 and positive 10? Negative 2. You'd minus 4x to get all the variables on one side. That makes it 22 equals 4x minus 2. You add 2, that makes it 24 equals 4x. Divide by 4, and 6 equals x. Again, that's what x equals to. Make sure you read the directions to see what it wants you to do with that. Okay, guys. Anything about trapezoids that you need to ask about? I know it's a lot, but trapezoids have a lot of things that are unique about them. These are 2 shapes that are just kind of different than all the rest of them. Want to make sure we show you a little bit of everything. Okay, guys. Then the last of what we've got today is going to be about kites. Kites are weird. Guys, kites are strange. They do weird things. Here we go. This is a kite. So a definition of a kite, it is a quadrilateral because it's got 4 sides. A quadrilateral with 2 pairs of congruent consecutive sides. Of congruent consecutive consecutive sides. Now write it down, then I'll talk about what that actually means. It is a quadrilateral with two pairs of congruent consecutive sides. We've never had the consecutive sides be congruent and not all four of them be congruent. We have squares, we have rhombus where all four of them are congruent, but not where consecutive ones are congruent, but the other two are not the same as those. Okay, guys, congruent means they're the same, consecutive means right next to each other. That's unusual. Unless all four are the same, it's unusual for that to happen. In a kite, this side is going to be the same as this side. This side is going to be the same as this side. So you have two triangles that are the same as each other up here at the top. Then you have two congruent triangles down here at the bottom. But all four of them are not the same. That's what makes this different than a rhombus. It's two that are the same up here and two that are the same down here, but not all four of them are the same. Okay? There are some things, there's 4 different things you have to know about a kite. So let's get started. The first one, number 1. I'm going to kind of put like 1, 2, 3, 4. I'll put them in, for some reason the picture's in the middle. It should have been on the side, but we'll just write 1, 2 over here and 3, 4 over here. So for number 1, the angle between the congruent sides is bisected. The angle between the congruent sides is bisected. Angle between the congruent sides is bisected. The other ones are not, so it matters. So guys, what that really means is up here at the top, where these are congruent sides meet each other, this angle is going to be congruent to this angle, and this one is going to be congruent to this one. Those angles are cut in half. The ones over here are not cut in half, guys. These are not cut in half. You can tell this angle's not the same as this one. Only between the congruent sides are they bisected. Number 2. The angle between the non-congruent sides, the angle between, that's the E and the I, guys. The angle between the non-congruent sides are congruent. Or I guess it should be angles between. The angles between the non-congruent sides are congruent. Now that's a weird statement if I ever heard one. The angles between the two sides that aren't congruent to each other are congruent. What that means is that this angle right here, and I'll do it in a different color, it's going to be this angle right here. This whole thing is going to be congruent to this whole thing. And that's not true about K and T. K and T are not the same size. These are bisected, these two are equal. These are bisected, these two are equal. It matters. It makes a big difference later on. Okay, number 3. Number 3, the diagonal between the non-congruent sides is bisected. Y'all, it's so different. The diagonal between the non-congruent sides is bisected. And I'll let you write that, then we'll talk about what that means. Because only one diagonal is cut in half, the other one is not. That's what makes these so weird. Part of them is one way and part of it is another. So you got to know what parts are what. So the diagonal that is between the non-congruent sides is the one that goes right here between the E and the I. This diagonal is cut in half so that this piece right here is congruent to this piece right here. That would mean ES is congruent to IS. ES would be congruent to IS. Now, KS is not the same length as ST. It's not cut in half that way. It's only cut in half between the non-congruent sides. Okay, last thing. Guys, look at the diagonals. What do you think's true about these? How do they intersect each other? 90 degrees. So the diagonals are what? There you go. The diagonals are perpendicular. Very good. Diagonals, that's the easy one, I saved it for last, are perpendicular. The diagonals are going to be perpendicular, so you're going to have right angles all there in the middle. Nice. The diagonals are perpendicular. Now, the main thing that you do with kites is basically take them and break down all the sides and see what it is that you can get out of them. Okay, you're going to give me the angles, you're going to give me missing pieces, and so because of that, you're going to need to know all these rules. Now, these rules are strange. If there were any rules I'd be writing down and trying to practice, this would be it, because these rules are weird. The more problems you do with this, the better off you will be, because kites don't work like any other shape. So, anybody still writing before we go to the problems? Okay, here we go. So for these problems, guys, this is a kite. It says find the measure of angle B. Well, in this kite, this side would be the same as this one. This side would be the same as this one. So these are the angles between the non-congruent sides. What do we know about the angles between the non-congruent sides? They're what to each other? Congruent. So this angle right here would be 110. Not complicated, you just need to know what the rules are to know what it is. The problems are not hard, but you have to know the rule and what to do. Okay, for this next one, we have two things to find. We are finding angle KON. KON. Guys, this angle right here, KON. KON. We should know that automatically. It's a kite. That's going to be what? 90. That's automatically a right angle. 90 degrees. The next thing it wants me to find is NK. Guys, if this piece right here is 5, I just traced the wrong one. If this piece right here is 5, this is the diagonal that's between the non-congruent sides, then this side over here would also be 5. I now have a right triangle. We know this is a right angle, so I know this is a right triangle where I know two sides in a right triangle, and I want to find the third one. What do I use when I know two sides in a right triangle and want to find the third one? It's that one with the P. Pythagorean theorem. There you go. So we are going to use that a squared plus b squared equals c squared. A squared plus b squared equals c squared, guys. So the way that we're going to set this up, remember the c has to be the one that is across from the right angle. So the 5 and the 8 can go any order. I'll do 8 first just to show you it doesn't matter. It doesn't have to be big, small, small, big, doesn't matter. 8 squared plus 5 squared has got to equal x squared. Well, 8 squared is going to be 64. 5 squared is going to be 25. And x squared is going to be x squared. What's 64 plus 25, guys? 89. Oh, you're going to have to round this one. Guys, how do we get rid of a square?
Square root.
Square root. Okay, guys, we're going to tell you that you're going to need to round to the nearest 10th. Round your square roots to the nearest 10th. What's that give you on the calculator when you round to the nearest 10th? 89, hit the square root button.
9.4.
9.4. What's after that, just so I know?
3.
Okay, so just stop at 8. Oh, wait. 9.4 with a 3 after it?
9.43.
Okay, perfect. So a 3 would mean that it stays the same. You don't round it up. That's exactly what you'd need. Nice. Okay, last two problems today. Okay, let's see if we can take a look. Anybody still ready? Okay, here we go. Last two. Guys, this one's going to blow people's minds and mess this up. Guys, every four-sided figure adds up to what? 360. What do I know about these two angles between the non-congruent sides? They're congruent. Okay, So to do this problem, I am going to add 42 plus 30. What's 42 plus 30? 72. I'm going to subtract that from 360 because we're in a four-sided figure. What is 360 minus 72? Sorry, I interrupted. 288. I apologize. You started talking when I was still asking. I apologize. That's my fault. I cut you off. Okay, from there, guys, that 288 is for both of these angles. Because we know they're congruent, though, what can I do to that 288? Divide by 2. No issues with that. So that puts you at 144. Good. So each of these angles would be 144, which in this case, the one we're looking for is D, but it doesn't matter. They're both 144. That's the answer to the question. Okay, last one. Guys, these should be very easy for you to do when they ask you these angles, because they're going to ask you this angle, I guarantee it. What's the angle MOL? 90. MOL is going to be 90 degrees. And then we're trying to find OM, which is this piece. Now, this is Pythagorean theorem again, but it's a different part of it. We're trying to find this part. The C, the last one, has to be the one across the right angle, so this one has to go last. The X and the 9 can go in any order. I would write it as X squared plus 9 squared equals 15 squared. Okay? X squared plus, what's 9 times 9, guys? 81. 81. What's 15 times 15? 225. 225. We're going to minus 81. Minus 81. It's going to make it x squared equals 144. Y'all type quick or do stuff in your head very fast. And then take the square root. Now, y'all know what the square root of 144 is, guys. 12. What's that? What was it? 12. Perfect. 12. So the length of OM would be 12. Yes, ma'am. Every time, because you can't leave it with a square on it. Good. Anybody else? Okay, guys. Now, I'm going to cut a couple of problems out of your homework because we took longer on your notes, so I want to pass this out so I can get you to cross some out. There's not a lot on it to begin with, but I still want to cut it down because I don't like time. I don't want to give you a ton. I just want you to practice this a little bit because we're going to do it again tomorrow. But when you get this, we need to go through and cross some out. So get this and let's pay attention and get this crossed off. So I want to make sure you do them, but I also want to make sure that you don't do too many of them. There's more than that. Let me get you on these. Okay. So we are going to cut a few problems.